Hello, and welcome back to the Next Frontiers of AI podcast, our first in the year of 2026. Our objective is straightforward: to partner with industry pioneers and cut through the hype so leaders can understand what is changing, what is real, and what is next. I'm your host, Scott Hebner, Principal Analyst for AI at theCUBE Research, and thanks so much for tuning in. Today, we're going to make a forward-looking call that I believe will define the next frontier of AI adoption. 2026 will be the year of AI decision intelligence, the year that it goes mainstream. If 2022 through 2024 was the surge of generative AI, and 2025 was the rise of AI agents and agentic workflows, then I believe the next frontier is clear, and actually it's inevitable. As we wrapped up 2025, I think it's fair to say that enterprises are hitting a hard wall, driven by a single word: trust. They have AI systems that can generate. They have systems that can analyze and summarize. They can even act autonomously at times. But when decisions become consequential, most of today's AI still struggles to explain, justify, defend the decisions, and not to mention not be able to audit them. And this is not theoretical. A timely catalyst underscores why this matters so much right now. A new study published just a week ago by one of the top AI universities in the world, Carnegie Mellon, clearly highlights the challenges enterprises face in 2026 and beyond. The study's findings were sobering. While AI agents powered by LLMs appear to reason through tasks, 74% of their explanations are post hoc narratives, essentially post-decision, logical sounding stories that mask simple statistical shortcuts. For decision-making and compliance, this means the current AI audit trails are 74% unreliable, making them nearly impossible to use and rely on. The implications for enterprise AI are stark. Just saying because the model told me to do it is not an audit trail, nor is it a prescription for accurate and trustworthy decision-making. The good news is that things will likely be very different starting in 2026. This year will mark the rise of AI decision intelligence that will be fueled by the emergence of new AI technologies that PhDs have been incubating in research labs for a long, long time. They're now being democratized for enterprise adoption through new tools and platforms. Today, joining me to unpack all of this is Joel Sherlock. He's the CEO of Causify. Causify is focused on bringing decision-grade intelligence to the point of action, using causal modeling to accelerate insight, reduce risk, and make AI-driven decisions more explainable, reliable, and repeatable at enterprise scale. So I'm excited to welcome Joel to the show here. Let me bring you up. There you go. How are you?
Well, Scott, thank you. I didn't know this was the first episode of the year. I'm honored.
It is the first episode of 2026, coming out of hibernation from the holidays. It's been a few weeks since I did one, but yeah, and I think 2025 was a fascinating year. I mean, the whole rise of agentic AI. We went from everyone talking about Gen AI to, now we're into agentic, right? And,
for sure.
Or into agentic, and now the question is, what is 2026 going to be all about? And you kind of got my view already, which we're definitely going to talk about. But before we do, let's talk a little bit about you. Why don't you tell us a little about your journey to where you are today and what led you to become the CEO of Causify? And what does Causify do, and for whom, and why now? Why do people need to get involved with you?
Well, yeah, really, really interesting. And I'll try and compress it to not take up all of these valuable minutes with the backstory. But so, we kind of have been at this long before this big surge recently. The surge recently has unlocked a lot of horsepower at Causify. But my two partners, one is ex-Google PhD mathematician, and the other is an ex-NVIDIA on his third startup, and he's a PhD in computer science and machine learning. I come out of the commercial side. I've built many things, from tech businesses and real estate all the way to tech-enabled manufacturing, and so really a very dynamic team that has built Causify. But we've been at causal systems and probabilistic decisioning systems specifically, starting on Wall Street and quant trading, where millions and billions of dollars are at risk, and audit trails are table stakes. It absolutely has to be explainable, because the systems in that world are delivered to a hedge fund manager or the trader. They look at it, they have to see the logic, they have to test the logic, they have to be able to back test and counterfactual, what if this, and then they make a decision, and only then do they make the decision. So, there's a really interesting, everything you were explaining about that trust side. It's something we talk about a lot.
Yeah, all the survey work, all the engagements that we've done here at the Q Research, if there's anything that pops to the top, it's trust, which is, by the way, a highly, it's a multidimensional word, right? I mean, it's user trust, it's security, it's compliance, it's data integrity. There's a whole bunch of different elements to it. But in the end, if people don't trust it, they're not going to use it. And that's why that focus needs to be there. And you kind of hit on this, but, clearly most enterprises have LLMs and generative AI deployed, either in-house or they're using some of the publicly available. But in your view, what are they starting to realize that those things can't do reliably? And, what priorities do you see emerging?
I mean, the interesting part for us is like, oftentimes it's kind of like causal versus, the LLM systems and what's out now. To us, we really see it as and. There are some decisions that need audit trails. You need to be able to explain things. I mean, most AI systems today are really good at predicting, what might happen next, right? But prediction isn't decision making. Like, real decisions they require an understanding of why something is going to happen, and then ultimately what changes if you act differently, right? It's really more in line with how humans think, right? Causal AI is kind of built for that. It doesn't say like what's likely or what has happened in the past. It says, because of these things, we predict this will happen with this strength of prediction. And if you intervene here, these things will change, right? The beauty of those causal graphs is we're really teaching the system to understand how the world works and how different actions will change probabilities.
Yeah, I think that's right on. I mean, I've come down to like 4 speaking points on my stump speech, right? Which is, given the world that everyone's sitting in today with LLMs and RAG and even chain of thought, is first of all, data is not knowledge, right? 2, a prediction is not a judgment. 3 is that correlation doesn't imply causation, right? And you need all 3 of those. You need the knowledge, you need the ability to have AI help you make judgments, and you need to make sure you don't confuse the statistical correlation with cause and effect. You need all that to make a decision. I mean, humans need all that to make decisions, and therefore AI is going to have to figure out sort of how to replicate that. And that's part of the reason why I think, 2026, I think, is the year that people are going to really start to understand that and be looking for ways to move from automation into the world of AI decision making. I'm just curious. I think I know your answer, but
yeah, I mean, I've got a lot of answers, and so we've been at this, and we certainly believe like we're starting to see a lot more conversations on this topic, right? This absolute explosion of these tools, very, very powerful tools, right? That are now making their way into the workplace, and they just solve a lot of problems, but we have seen them being used in areas where maybe they shouldn't be solely relied upon, right? An explanation that sounds good isn't the same as one you can defend. So in high stakes environments, which is where we work, right? Taking that logic from Wall Street, bringing it into energy markets or supply chain or a lot of the other things that we work on, you need to show why you're recommending a decision, or after the fact, why that decision was made, right? What assumptions were used, what alternatives were considered, and causal AI gives you that trail. In some markets, it's an audit trail. In some markets, it's an explainability trail. But what we find is that's far more aligned with how humans make decisions. And so, and it also, it's that confidence piece that is missing from a black box prediction machine. Those are phenomenal tools for some uses. But when you bring them into high stakes decisioning, it's tough to say I made that trade because the LLM told me to. That would never stand muster.
Yeah, and you got all these regulatory compliance challenges, right, across industries, across states, across geographies, across the world that are, a lot of them are different, right? Consistent maybe,
Yeah.
but different. Then I know in the United States that overriding all that, not overriding, but above all that, I think it was Delaware passed a fiduciary law or regulation that basically said that as a corporate officer, you cannot just say, well, the AI told me to do it. That's not good enough anymore. So that's going to put pressure, personal pressure, financial personal pressure on corporate executives to make sure that their organizations know what they're doing with AI and that things are, yeah.
And I mean, as an executive, I think you've got to look a few orders down, right? Because as an executive, you get a lot of information being brought up from this is my COO, that's from my CFO. But if they're using these systems and blindly trusting them and not checking that work, you could actually be getting fed incorrect information and not even know it. And you're not relying on an LLM. You just didn't know that one of your, second in charge was. And so, it's difficult because a lot of these chain of thought reasoning pieces, like when you look at when documents disagree or language models often, average or hedge or hallucinate is a term we've all heard. They don't truly reason through that conflict. Causal systems do, right? They model directionality or dependence and they reconcile sometimes conflicting or smoothing, but as you layer different pieces on top, and a mistake here can kind of really create problems later.
Yeah, that's 100% right. And I think some of these companies like ChatGPT, OpenAI and others have bastardized the word reasoning with chain of thought. And that's one of my first papers that I wrote at the Q Research was actually on that. Was it's not really reasoning. You can't reason, without reasoning by default, by definition is a function of cause and effect. Alarm clock goes off. Do I hit snooze or not? Well, you're doing cause and effect. Well, if I sleep in, this is what's going to happen. If I don't, I'm going to be, and chain of thought just goes back and rethinks things on the process, but not necessarily. But to the point, go ahead. You were going to make a point.
Well, yeah, no, I was going to agree with you entirely. Yeah. And then, but these tools do have a place. And frankly, I mean, when you have a causal system that is, working with a lot of the other powerful tools that exist, you add causal reasoning, but those systems can be phenomenal for gathering, testing, or organizing information. But like what happens is traditional machine learning works really well until the world changes, right? And then it breaks. Regimes shift, markets shift, supply chains snap. Correlation-based models assume tomorrow will look like yesterday, right? Yeah. Causal systems don't. They're mapping actually the drivers that cause and effect. They model the mechanism, not just the patterns, right? Those patterns are important priors going into a system, but they don't, the past does not author the future, right? And when you kind of make that shift, number one, it aligns more with how humans think. So that's driving trust. It can be explained. That's driving trust. And you can map, what if I did this versus that? Drives trust again, right? And so they're far more resilient when conditions change. And we know that the only guarantee is change. And that's really where decisions matter the most in the world that we work in.
Yeah. We're gonna be best friends. I mean, I love that. And I think that's right on. I mean, one of the things I've been telling people is that today's systems, LLMs, are basically only as good as you want your future to be exactly like your past.
Yeah.
Right. And by the way, just let me say it up front, is I've always equated the LLMs, the generative AI, as the equivalent to the browsers, some 30 years ago, the browser wars, and your whole business is going to depend on what browser you selected. And it turned out that they basically became a gateway into the world of online, and it was a preference at best. And I think LLMs are an absolutely critical part of the stack. Don't get me wrong, but they are a gateway into the world of AI, right? That's what people interface with. It's how you build around it to make it useful. And so
For sure.
LLMs and generative AI, I think, is a step on the stack. And to your point about, let me bring up a chart here, which is
Yeah.
and we didn't coordinate any of this, but you said it, and about the
great book.
world. Yeah. So for everyone that's watching this, the Book of Why by Judea Pearl, he is known as the father of causal math. So really eloquent math that basically, is the new science of cause and effect. And when you hear causal AI, causal inference, causal ML, it's basically modeled off the theories and the approaches of this book. So two quotes I love to talk about when I'm pitching this stuff, right? One is from Aristotle, like a long time ago, right? If you prove the cause, you at once prove the effect. And conversely, nothing can exist without its cause, right? So that's I think an important concept, right? But one of the quotes from the book from Judea Pearl reflects what you just said, Joel, right? That while probabilities, statistical probabilities like LLMs, correlations, all that, encode our beliefs about a static world, causality tells us whether and how those probabilities change when the world around us changes. So bingo, right? It's always, we live in a world where it's always changed, and you want it to change, you want to improve. So, it's an important element that needs to be incorporated to AI systems, and that's why I feel it's inevitable.
Well, in Dr. Pearl's book, he talks a lot about, data alone is not enough, right? Having data, reviewing the data is better than none, but understanding why or understanding the context of that data is almost as important. It's kind of that quantum leap again in that direction. But, I should also call out that what we are doing wouldn't be possible in the way that we're doing it without these tools, right? You go back to, Wall Street, alternative data funds if you're looking at oil or if you're looking at technology, you would need really expensive humans and the best in class people to come in and help you design that map, right? That's not really scalable. That's not all that quick, and you'd need huge budgets for it. And so causal decisioning, I believe everybody would agree it's the pinnacle, but it's been very hard to do cost effectively and at scale. But, with the advancement of a lot of these tools we're talking about, now you can use this methodology with those tools, unlocking, the audit trails, the explainability, the counterfactual, like all of these things that have been missing. But it's a fundamentally different system, right? Like you had talked about the, post hoc explanations, right? LLMs are really good at explaining their answers, but they didn't use that explanation that they might give you wasn't used in their decision making. So they make a recommendation and then they make up a story that sometimes sounds plausible, most of the time sounds plausible. But that post hoc rationalization, like causal systems flip that, right? It's the reasoning is the driver of the decision, right? The explanation isn't a story that's sort of layered on afterwards. It's the engine underneath that's driving those recommendations. So we feel it's extremely important, and the numbers, will tell you if it's in energy market predictions or, hedge funds and their return ratios, or, a lot of the other markets. Supply chain has been something that or machine failure prediction, right? It's just, it gives users an unfair advantage.
Mm-hmm. Yeah, and technically, I think what goes on here is you have the LLMs operate on statistical probabilities, right? Correlations, patterns, anomalies, and they are able to process massive amounts of data through that, which is a good thing. And that's used to make predictions, right? And predictions are, in fact, statistical predictions. And for the companies that show and say that they can provide explainable AI on an LLM, what they're actually doing is predicting the explanation, to your point.
Yeah.
It just compounds the problem, because then you have predictions laid on top of predictions, and it's not a sustainable model if you want to use AI to actually make a decision.
Well, exactly. And when you look at the encode decode side of that, I mean, it like AI LLMs, it's the explanation that if it doesn't match it's not because it was actually mapping, right? Like as you're saying, it's just looking for patterns and making predictions. It's not a bug when it gets it wrong. It's a design flaw, right? They're optimized to sound coherent. They're not optimized to internal reasoning, like a causal graph or a causal system would be, right? They 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 make assumptions and they're not traceable, and that is by design, right? That's how those systems work. It's the opposite in a causal environment.
Yeah, and the way I think enterprise leaders should think about all this is that when it comes to AI, your LLM and RAG and chain of thought, that is not your architecture. That is a component or a layer of your architecture. And I think it's a critical component. You absolutely need it. You need the models. What we need to do is layer on top of it additional capabilities and technologies, almost an ecosystem of models that become your architecture, right? And we'll get into what you guys do to help build that next layer in a second. But let me bring up, I mentioned Carnegie Mellon earlier. Let me bring up
please.
A couple charts that I actually had Gemini help me translate because it's highly technical. But here's the point on why LLMs can't be trusted. So what they found is that the perception, and by the way, I think it was like 1,600 and something questions using 50,000 RAG retrieved, right? So it was a pretty comprehensive study. And, the perception is that, it's a logical chain of thought. It helps you make accurate decisions. It gives you a reliable audit trail because it explains to you why the decision, right? But the reality is it's heuristic shortcuts, right? Repetition over facts. It's really fabricated explanations. It's predicted explanations, right? And what they showed in the study is a 74% failure gap between what people think and the reality. In other words, the LLMs made decisions, high conviction decision on the wrong reasons, and the documents that they say they used, they actually didn't use. So what that equates to is 74% of LLM explanations are basically developed after the decision was made, right? Versus, how the decision was made. And that equates to 74% of the explanations are really not audit ready, right? They're just not reliable, right? And I think that's your point about the audits.
Well, and Gemini, deep research, all of these tools, like they're phenomenal. And ultimately, if you're comparing the size of two different markets, I mean, that's my first go-to for a lot of, I don't go and Google things as much anymore, if any. But so I use these tools and we use these tools in our own systems. But when it really boils down to what is the decision and, do I need to be able to audit correctness, right? If it's a serious business decision, if it's this market over that one, you probably want to go and vet the numbers that these systems are giving you, right? I mean, a causal graph is essentially a map of how the system believes the world works, right? When you have that, when you can see it, you can inspect it, you can challenge it, you can test it. If you're going to make a trading decision, you probably want to see all of the back tests. You probably want to see the assumptions that are being made. And so in a causal graph, you can inspect each piece, right? It's critical to us for enterprise decisioning. The regulators are going to want to see it. Your board is probably going to want to see it. And so you can't audit, black box probability, but you can audit cause and effect. So from like the audit and compliance world, we feel that is, both in the probabilistic decisioning advantage you get, but also in the explainability side, we think, I would agree with what you're saying. There is a future, and this is, a big driver of that.
Yeah. And a lot of people are talking about knowledge graphs, which I think is a big step in the right direction, right? Because that gives you relationships and context, some degree of perception on how things relate to each other. But the knowledge graph itself does not, even though there's a relationship between entity A and entity B, it does not tell you what caused, does A cause B or B cause A or neither. And, an example in your world of manufacturing is like, you have a pipe that has condensation and there's humidity in the room. Okay, great. So how do you know whether it was the condensation on the pipe that caused the humidity, or was it the humidity that caused the condensation on the pipe? Because there's different remedies to what you would need to do, right? And a knowledge graph will tell you there's a relationship, but it won't tell you the cause and effect, which without the cause and effect, you can't make a decision. So it's not brain surgery. I mean, it's common sense, right? That eventually, I think that's why it's inevitable.
And when you break it down, you going back to like spurious correlations. Judea Pearl talks a lot about this, but like if you look at the rise of ice cream sales and the rise of drownings every summer, maybe a little morbid, but a quote from the book, those aren't correlated, but every summer you will see them go up together. And, when you understand the context of that, you would easily be able to know, sure, because it's summer. But if you're just looking at charts and you don't understand the charts, you're going to say, hey, this is the price of Mongolian butter and that's Apple shares. Great. Those must be linked. I can assure you they're not. Right. And when you come back to like how businesses ask questions, we believe that businesses don't ask what will happen. They want to know what would happen if we do this instead of that. What if we did this, how would that affect our decision and what risk would it be, right? LLMs struggle with, that type of question. Causal systems are built for it, right? You can simulate alternate futures before you commit real money, people, risk, etc.
Yeah, what if counterfactual reasoning, you can actually rank if there's 150 influences or variables, if you will, on an outcome, you can actually rank them from 1 to 150 on what has the biggest. I mean, because it understands all that, right? And to your point about the LLMs, let me go back to the Carnegie Mellon thing one more time, sort of the next level of detail here. And let me kind of go through this, Joel, and then you can give me your 2 cents on it. But basically what they're saying is, look, from a user perception, they think the model is, weighs facts and truths, right? But the reality of it is the model is driven by repetition and signal strength, not facts and truths. The perception is a transcript, it produces a transcript of the AI's thought process. Well, as we said before, that's not actually the case. It creates an ad hoc narrative after the decision is made. They think stronger facts carry more weight, as they should in real life. But actually, if you repeat nonsense over and over again, it outweighs a factual logic. And they talk about this in the study. You would think the user perception would be that they know, the model knows what convinced it to make a decision, when it actually can't identify the causal triggers for its reasoning. It also showed that just because the model gets bigger and bigger and more sophisticated, a 70 billion parameter model is actually less accurate for making decisions than an 8 billion model. And part of what they do in the study, because they're more resistant. The bigger it gets, the more resistant it is to new evidence, right? And so this whole idea of stable versus, paraphrased redundancy, and so just the way they work do not lend themselves to accurate and trustworthy decisions. They can inform you so you can make a decision, but I think enterprises want the AI agent to partner with a human being to help them make better decisions, but actually be able to help you problem solve, diagnose. Yeah.
And it's our belief, or like our team talks a lot about this, is the AI agent that's coming more and more into all parts of business. They're extremely powerful, but one of the huge risks, if there isn't sort of cause and effect or an understanding of this, right? One of the most dangerous traits I feel of AI is that it's confidence when it's wrong, right? I heard this more, so that must be true, right? Causal systems naturally model that uncertainty, right? Shows you what ranges, sensitivities. I was 2% sure of this. You might want to go and dig into that a little deeper, right? And again, being able to go through and audit all of those pieces, really that's to us how humans make decisions. Well, why? Where did that come from? Do we believe that? You get to test or challenge. all of the pieces to that chain of thought that brought you to the end. And that's something that's inherently, far more feasible in a causal environment with that causal graph.
Yeah, a real life story just from a few weeks ago, and I have the transcript on Grok, and basically in the middle of the night I had like a really bad stomach ache, so I was asking like, what do I do? And it basically got to a point saying, well, you should really go to the hospital. Better there than dead in your bed. I said, okay, well that's pretty straightforward, pretty crazy.
Yeah.
And then it basically started asking me, and I basically told him like on my last physical I was like borderline low on potassium. And it wanted to bet me money that I would be low on magnesium. It's magnesium that can, cause your stomach to go wacky. And go get a magnesium test. So I went and got a magnesium test, and I was borderline high. So it was wrong.
Right.
So got to be a little bit careful with these things. But back to your point, let me just bring up one more chart here from the Agentic AI Futures Index that we run on Causal AI. What do you consider the primary business drivers for adopting causal AI in your organization? And look what they are, right? Obviously, you want to improve decisions quality, but the explanations and the auditability, to your point, Joel, right? Hidden drivers of change, right? Actually understanding the causal drivers of your business, right? Which could be different than statistical, the root cause analysis, capturing human expertise and intuition. And notice at the bottom, only 16% didn't see a use or a value for causal AI once they understood it. And this was 625 pre-qualified AI involved people in enterprises across the UK, Canada, and the United States.
Oftentimes, anyone who is against the causal side, it's like, that's going to be cost prohibitive. That would take too much time. I need to make my decisions faster than that, right? If I need to bring in humans who can design these graphs for each of my queries, that's not scalable. And maybe that is, causal systems of old. But, when we talk a lot about trustworthiness and auditability, right? And to us, trustworthiness isn't about persuasion. It's about structure, right? When you can see how decisions were made, that trust naturally follows. Sometimes you don't need that. I need this picture. I don't necessarily care how it was made. Nano can just make it. That's fine. But I need to make this trade. Should I open a warehouse here or should I open a warehouse there? What are the pros and cons? What are the advantages? What are the risks? That's just, once we align on that structure side, we feel that trust follows. So I see the future not necessarily as LLMs versus causal, but almost right. LLMs and a causal on top, or them working together in a very, very important way. But that decisioning layer, we believe, if you need an audit and you'd value that explanation, you need a causal system.
Yeah. And what I've seen is the architectures, or you have an LLM, and then you have a causal model, and as the model, the causal model feeds off the information from the LLM, it helps discover and apply causal drivers and causal effects, and then educates the LLM. So you have a cycle where the whole system gets smarter, right? And of course, you have some knowledge graphs in there that may just be capturing human expertise that may not have.
Yeah.
So you're building out an architecture, and then you got multi. You got the MCP for agents. So it's an architecture, and LLMs are a component of your architecture, just like a web browser used to be a component of your e-business, right? And that's
going on. Now if we look at how Causify in our systems work, if you were to take your example there and add in a system that understands time series data and can do very strong back tests, so meaning that when we made that decision in January of 25, what was knowable at that time? So time series systems can blind themselves to, stop future peaking, right? When you're doing a back test, and as of this date, you want to make sure that it's only using the info that was available on that date. And then in that back testing environment, if you can test, change the graph, run a counterfactual, and be able to explain, here is the predicted outcome in confidence if we went this way, here is the predicted outcome in confidence if we went that way. I think those, we believe those are extremely powerful systems in almost every business, right? We are working in a lot of exciting markets, not all of them yet, but there's some real value that comes out of this type of architecture.
Yeah, I encourage everyone to go out to Causify.ai. Actually, it's right next to Joel's name there. But I think you do a really good job out there on outcomes, like the bottom line business outcomes. You want to just summarize that real quickly? What customers can actually choose from this? Yeah.
Yeah, I mean, looking at financial markets, of course, there's so many really powerful tools there, and our Optima models run, alternative data hedge funds or multi-pod funds, and there's a lot of advantages there. We've got a whole team dedicated to Wall Street and the financial side. We've also got into energy markets. So specifically there, giving a 7-day forward look in someone's grid. So if you're a power trader or a Bitcoin miner, you can see the volatility and price with confidence. You can make better decisions, right? Looking at the work we're doing in supply chains, if you know what you need to order and where you need to have it, that can save millions to customers' businesses, especially if it's probabilistic with confidence and full explainability, right? Yeah. And now we've got into some other exciting side, from predicting when windmills will fail. So predictive maintenance using SCADA information mapping those failure patterns and saying, hey, we're watching a problem on number 2. We're just keeping an eye on it. But there's a problem on number 4 that is 87% going to be catastrophic in this amount of time. To our customers, that is incredibly valuable insights because it helps them, with that decision intelligence, making decisions confidently with a whole lot more data than an army of people could compute.
Yeah, and I think that's the whole idea of root cause, I think, is really critical because actually where I see the most causal AI adoption, and this has been over the last couple of years, have actually been in IT observability platforms, systems management platforms. Like IBM, I think, was one of the earlier companies to actually have causal AI in their IT management systems because with the purpose of identifying root cause, because once you know a root cause of something, then you can help remediate it. If you don't know the root cause, right? Just looking at numbers saying, yeah, it fails, it's likely to fail, but if it doesn't tell you why, then right, you need that root cause. And what you just said about the windmills, and you can start with where this becomes root cause is a part of every business. There's always root causes, right? I mean, even as a marketing guy, I remember being yelled at IBM all the time about, I can read the damn chart. I can see the pipeline. Talk to me about root cause, right? And now we have a way with causal AI and decision intelligence to actually get some real insights on what's causing things.
And we believe it's that temporal structure that's kind of essential for understanding, right? Because a lot of ML systems focus on similarity. This looks like that, right? Those causal systems focus on the sequence. This led to this, which caused that. Then the temperature spiked, whatever it could be, and then you can go backwards, right? So that root cause can also be tested backwards. Was it this or was it that? And you can look at, how those problems and how everything is linked together. I mean, it's the beauty of getting that SCADA information into a system like this is you can really map each step, not just, hey, temperature spiked or vibration went up.
That's one of the values of running it in conjunction with an LLM is you can actually use the causal models, which is, I think, one of the points you made a couple of times during this talk, to actually understand the causal drivers of your business. Like, how does your business, not how you think it operates, how does it actually operate? And what causes what? And what's the chain of effect to an ecosystem?
And if this is how you believe your business operates, once your data goes through a system like that, it will tell you if it actually operates that way or it doesn't as well.
Exactly. That's our goal.
We feel so, yeah.
So we're getting close to end here, but I wanted to, one of the things I really like that you're doing is democratizing this for enterprises. So let me just show you a couple quick charts here, have you comment on that, and also maybe give some advice for people how to really kind of get started. But let me just real quickly here. So this is, again, the Agentic AI Futures Index. On the left, so clearly there's an investment stream over the next 18 months in decision intelligence. The use cases are moving from automation to knowledge work being defined as having to make judgments, which is code word for decisions, right? However, they see a barrier, and the barrier is the difficulty of implementation, or the fact, or how do you integrate this into our AI stack? And one of the questions we asked was, if causal AI were more broadly integrated into agentic AI tools and platforms, how would that impact your organization's adoption? So what the survey basically said was, there's a lot of interest in this. There was a high degree of knowledge about what it actually is, like near 70%. But there was a feeling that it was too PhD-ish, too complicated for my team to actually use. But as you can see on this chart here, if you add that and select use cases, you're getting close to 70% would actually start to use causal AI if it was made easier. And that's one of your key messages, right?
That's what we do.
Yeah.
Our set of tools, from data ingestion, that time series database, the model building environment, and the causal graphing tool. When you bring those 4 modules together, we can make causal systems quickly, accurately, repeatably, and cost effectively. Yeah,
it's amazing stuff. It's gonna be exciting. I think, I know Gartner's had it on its AI hype curve for some time.
Moving along. Yeah. We're still in the early stages of it. And that explainability definitely, has come a long way in the last 6 months. And I'm excited to see, as we've got more of these in-market proof points, because you're right. I mean, when you even picking up Judea Pearl's book, those are, there's a lot of technical details in that book.
So we're coming up to a commercial break, as they say on TV. Real quickly, what would be your advice to any of the leaders that are watching on, like, what do I do to get more educated and to get involved in trying some of this stuff?
I mean, I would look at the decisions and how you're working on them currently, right? If that explainability or that counterfactual side, if you're really making high stakes decisions, I would highly encourage you to think, do I have the explainability? Do I have the audit trail side? If you don't, and that's important to you, take a look at causal systems. If you ever want to have someone from our team, explain how it could work in your environment, just reach out. We're happy to have those chats all the time.
All right, great. Well, Joel, look, thanks so much for taking the time to be here today. This is a great conversation. I think a lot of great insights, and I'm so happy to see the progress you're making with Causify.
I really appreciate you having me on, Scott. Thank you.
You bet. And, I think today's takeaway is quite simple, right? AI agents will not become truly decision grade on just LLM fluency and retrieval. And decision intelligence needs to go mainstream, right? And this is what's going to allow decisions not only to be more trustworthy and more accurate, but explainable, auditable, which is, to Joel's point, absolutely critical. So again, a big thanks to Joel Sherlock for joining us. Make sure you go out and check out their website at causify.ai. If you found this conversation useful, please subscribe, share with your colleagues. We'll continue to share the work we're doing here at the Cube Research. Thanks so much for listening in. Really appreciate it. And we will see you on the next round very soon. Take care, everyone.